Hello everyone! In this video, we're going to define the terms and concept in problem solving. And also, we are going to employ inductive and deductive reasoning in problem solving. Every day in our life, whether we're a student, a parent, or an ordinary person, a business person, or the president of the country, we always face so many problems that need solving. For example, you want to buy your favorite pair of shoes, but you don't have enough money, or you want to travel from one place to another by taking the shortest distance if possible. Whether the problem is big or small, we all set objectives for ourselves, face hardships, and make every effort to overcome them. But what you might not know is there an easy way to arrive over and over again, an effective and satisfying solution? There is a common and essential way to answering problems, and that is through problem solving. But why do we need really ne- but why do we really need to learn problem solving? So we all know that the word problem may have different meanings depending on context. So in English, a problem is any question or matter involving doubt, uncertainty or difficulty, or a question proposed for solution or discussion. In business, a problem is a perceived gap between the existing state and a desired state, or a deviation from a norm or a standard or status of a problem. So, in mathematics, a problem is a statement requiring a solution, usually by means of mathematical operation or geometric construction. So, our focus here will be problems in mathematics. So, prior to be detailed discussion in problem solving, it is important for us to understand first these three words. So remember the three words that I'll give you: method, answer, and solution. The word method means the ways or techniques used to get answer, which will usually involve one or more problem solving strategies. On the other hand, the word answer means a number, quantity, or some other entity that the problem is asking for. Finally, the word solution is the whole process of solving a problem, including the method of obtaining an answer and the answer itself. So we can summarize the discussion that we need to remember the words method, answer, and solution. Or we can use this equation: method plus answer is equal to solution. Problem solving is a process, an ongoing activity in which we take what we know to discover what we don't know. It involves overcoming obstacle by generating hypotheses, testing those prediction, and arriving at satisfactory solution. Problem solving involves three basic functions. First, seeking information. Second, generating new knowledge. And third, making decisions. We also consider the mathematical reasoning. So, reasoning is an essential skills in mathematics, most especially in problem solving. It is also important in students' activities. When you say mathematical reasoning, it refers to the ability of a person to analyze problem situation and construct logical arguments to justify the process or hypothesis, to create both conceptual foundation and connections in order for him to be able to process the information. And also, with the development of mathematical reasoning, students recognize the mathematics make sense and can be understood. They learn how to evaluate situation, select problem-solving strategies, draw logical conclusion, develop and describe solutions, and recognize how those solutions can be applied. Reasoning uses also a statement that consists of two clauses. The first clause begins with F, and the second clause starts with then. These clauses are commonly known as hypothesis and conclusion. Inductive and deductive reasoning are two fundamental forms of reasoning for mathematician. So when you say inductive reasoning, that is the process of reaching a general conclusion by examining specific examples. And also this type of reasoning, so that forms a conclusion based on the examination. The conclusion formed by using inductive reasoning is called a conjecture, since it may or may not be correct. So it involves looking for the pattern and making generalization. So for an example of using inductive reasoning, when you notice that all the dogs you see around you are black and white, so you make the conclusion that all dogs in the world are black and white. So can you say for certain that this conclusion is correct? No, because it is based on just a few observations. However, this is the beginning of forming a correct conclusion or a correct proof. What this observation has given you is a starting hypothesis to test out. Inductive or deductive reasoning can be used when solving problems. So, the type of reasoning that forms a conclusion. So, again, this is an inductive reasoning. So use inductive reasoning to predict a number. So for example, we have 3, 6, 9, 12, and 15. So as you notice, we're going to add 3. Uh, to get the next term, you need to add 3 from the previous term. So how are you going to use inductive reasoning to predict the number? So we can say that each successive number is 3 larger than the preceding number. So thus we predict that the next number in the list is 3 larger than 15. So we can say that the next number is 18. Another, so we have 1, 3, 6, 10, and 15. Okay, so first, observe the pattern. 1 and 3. So if you're going to get the difference of the first two terms or the first two numbers, the difference is 2. And if you get the difference of the second number and the third number, the difference is 3. So you have a pattern na, okay? The difference of third number and fourth numbers is 4. So it's like the difference is 2, 3, 4, 5, and 6, right? So you can so you will notice that you're going to add 6 from 15, or by using inductive reasoning, the first two numbers differ by 2, or the second and the third number differ by 3. It appears that the difference between any two numbers is always 1 more than the preceding difference. Since 10 and 15 differ by 5, so we predict that the next number in the list will be 6 larger than 15, and that is 21. Okay, use inductive reasoning to make a conjecture. So again, what is conjecture? That is the conclusion formed by using inductive reasoning. So because it's either our conclusion will be correct or not. So given this, consider the following procedure. Pick a number, multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract 3. So use inductive reasoning to make a conjecture about the relationship between the size of the resulting number and the size of the original number. So you can think any number, okay? So let's say that the number is 5. So what is the first step, we need to pick a number that is 5, and then we need to multiply the number by 8. So if we multiply 5 by 8, that is 40, and then add 6 to the product. So we're going to add 6 from 40, so that will become 46. Divide the sum by 2. So 40 divided by 2, that is 23. And from 23, you need to subtract 3. So 23 minus 3 is 20. Okay, so how we're going to make our conjecture? So let's try another number. So we started with 5 and followed that the procedure to produce 20. What if we're going to use another number? So for example, 6. So 6 is the original number. It can be produced a final result of 24. So kanina, so ang ginamit nating number is 5. That is our original number. It produced 20. If we use 6, it produced 24. And let's say that is 10. No, the original number is 10. So it produced a final result of 40. And if we start 100, it produced the final result of 400. So from that process, or from that procedure, using inductive reasoning, our conjecture now is it gives the procedure a number is 4 times the original number. So the resulting result 4 times the original number. So that is our conjecture. So another. Okay. So but before that, so I'll give you first a short background what is the pendulum. So scientists often use inductive reasoning. For instance, okay, inductive reasoning to discover the time required for a pendulum or complete one swing. It's called the period of the pendulum. Depends on the length of pendulum. So one of the scientists, so this is Galileo Galilei, that is, he said that he measured the periods of pendulum in heartbeat. So as you can see, we have a data here, no? This is the length of pendulum or in units. So and this is the period of pendulum in heartbeat. So the period of pendulum in the time is the time it takes for the pendulum to swing from left to right and back to its original position. Let's try to answer the following questions. So number 1, if a pendulum has a length of 49 units, what is its period? So first, observe our data. So the period of pendulum in heartbeats here, and the length of pendulum in units. So if we have one period of pendulum, so we have 1 units. And if we have 2 period of pendulum, we have 4 units. And if we have 3 period of pendulum in heartbeats, we have 9 units. So in the given question, you can answer this. Why? Because in the table, its pendulum has a period that is the square root of its length. Thus, we conjecture that a pendulum with a length of 49 units will have a period of 7 heartbeats. Another, if the length of pendulum is quadrupled, and what happened to its period? Okay, so based on the data, so a pendulum with a length of 4 units, so this one, 4 units, has a period of 4 units that is twice of a pendulum with a length of 1 unit. So a pendulum with a length of 16 units has a period that is twice that of a pendulum with a length of 4 units. It appears that quadrupling the length of a pendulum doubles its period. Counterexample. So when we say counterexamples, what is that? So when we say counterexamples, this is a statement, is a true statement provided that is true in all cases. So if you can find one case for which a statement is not true, it is called a counterexample. Then the statement is a false statement. In other definition of counterexample, it's simply that is a contradict or the assumption and show that the statement is false. For example, so if we have every number that is multiple of 10 is divisible by 4. So before you give your conclusion on that given statement, you need to first you can try numbers multiple of 10. So let's try to list all the numbers. No, not some of the numbers multiples of 10. So let's check if these numbers are really divisible by 4. We can try 100. So if we can divide 100 by 4, that is 25. So that is 100 is divisible by 4. That is correct. So 120 divided by 4 is equal to 30. Also, 120 is divisible by 4. So meaning, multiple of 10 here is correct. How about 110? It's 110 divisible by 4? No, because the answer is 27.5. So we can consider a number divisible by 4. This number, divisible by 4, if what? If there is no decimal in their answer. So therefore, what will be our conjecture here? Or by the way, what will be the counter example? So with this example, we have shown that not all multiples of 10s are divisible by 4. So we call 110 as a counter example. Again, kahit at least one dyan, no, na merong isang number dyan na magiging false yung statement, that will be the counter example. So that is the only one in the given. So meron pa tayo dyan. Like for example, 150. 150 is not divisible by 4. So that is the counter example of this given statement, no? Another, for all number x, okay, the absolute value of x is greater than 0. So let's try, no, to find out or to conclude if this statement is true. So hahanapan daw natin ng counter example para maging false yung statement. So magle-let tayo ng x. So let x is equal to 0. Then, so we substitute in the given. So the absolute value of 0 is equal to 0. Thus, for all number x is greater than 0. So 0 is equal to 0, but in the given statement is greater than. And 0 is not greater than 0. They are equal. So therefore, for all number x, such that the absolute value x is greater than 0, this is a false statement. So 0 is our counter example. Another, x squared is greater than x. So let's find a counter example for this statement. So let x is equal to 1. Let's try to substitute 1 on the given statement. 1 squared is greater than 1. And 1 squared is equal to 1, is not greater than. So therefore, this statement, for all number x, x squared is greater than x is a false statement because 1 is our counter example. So 1 is our counter example. Next, square root of x squared is equal to x. So let's find a counter example. Let x is equal to negative 3. Then, the square root of negative 3 squared. So we substitute our value of x. So negative 3 squared, that is 9. Square root of 9, that is 3. So if this is 3 is equal, by the way, our x here is negative 3. So if our x here is negative 3, and then if this is 3 is equal to negative 3, and that is not true. Why? Because negative 3 is not equal to negative 3. So therefore, for all number x, the square root of x squared is equal to x is a false statement. So that is how to find a counter example. Okay? So let's start with the deductive reasoning. So when we say deductive reasoning, this is the process of reaching a conclusion by applying general assumption, procedures, or principle. Or we can say that this the process by which uh, the way of showing that certain statement follow logically from agreed upon assumption and proven facts that there is a need to justify every step with a reason. Let's try to have an example. If a number is divisible by 2, then it must be even. Okay, 12. So you can give any even number, no? 12 is divisible by 2, and that is true. Therefore, 12 is an even number. Another example. This example is using deductive reasoning. If A is greater than A and if A ang if an angle A and angle B are supplementary angles, their sum is 180 degree. So, if the measure of angle A is 100 degree, then the measure of angle B is equal to 80 degree. Okay. So, tinanggal ko yung degree. Kasi class, so pag may M na tayo dyan, meaning may measured tayo dyan, so tanggal na dapat yung degree natin dyan. So, this is another example of using deductive reasoning. Another, use deductive reasoning to establish a conjecture. For example, pick a number. Multiply the number by 8, add 6 to the product, divide the sum by 2, and subtract 3. So, our goal here is to find the procedure. Okay? Wait. Let's say n is the representation of the original number. So, that is first, we need to multiply. So, pick a number, multiply the number by 8. So, that is 8n. And then add 6 to the product. So, 8n plus 6. Divide the sum by 2. So, 8n plus 6, that is equal to 4n plus 3. How? So, 8 divide 2, that is 4. So, may iwang n. So, kaya 4n. Copy the operation, that is plus. 6 divided by 2, that is 3. And then, subtract 3. 4n plus 3 minus 3 is equal to 4n. So, therefore, how we're going to say for that? So, we started with n and ended with 4n. Okay? So, the procedure given in this example produce a number that is 4 times the original number. Next. Solve for, okay, by the way, deductive reasoning is commonly used in geometry. I know during your junior high school, you can encounter tables like the statement and reason. So, some of the students, ang alam lang nilang reason dyan is given. Okay? So, this is an example, an application of deductive reasoning. So, kung saan, we're going to find the statement and reason. So, from the given statement. So, solve for x in the equation. 3 times the quantity of x plus 4 minus 2x is equal to 20. Justify your answer. So, if our first statement, of course, the given. Okay. And then, we can distribute 3 inside the quantity. So 3x, so 3 times x is 3x. Copy the operation or the sign. 3 times 4, that is 12. Minus 2x is equal to 20. Kaya our reason for that is distributive property. And then, we're going to combine the common, no? Okay, the common terms or the similar terms. So we have 3x minus 2x plus 12 is equal to 20. So our reason for that is commutative property. And also, 3x minus 2x is x plus 12 is equal to 20. So our reason for that is closure property. And then we need to transpose or put 12 in the right side. So that will become x is equal to 20 minus 12. And that is transposition. So x is equal to 8 and that is closure property. So that is an application or how we're going to apply deductive reasoning. Okay, determine what types of reasoning, if it's inductive or deductive. During the past 10 years, a tree has produced plums every other year. Last year, the tree did not produce plums. So this year, the tree will produce plums. So is this inductive or deductive reasoning? So these arguments reaches a conclusion based on specific examples. So it is an example of inductive reasoning. Another, all home improvement costs more than this the estimate. So the contractor estimated that my home improvement will cost $35,000. Thus my home improvement will cost more than $35,000. So is this inductive or deductive reasoning? Because the conclusion, so as you can see, is a specific case of a general assumption. This argument is an example of deductive reasoning. Okay, thank you for this uh thank you for watching this video. I hope you learned something. Don't forget to like, subscribe, and hit the bell button para updated kayo for more video tutorial. This is your guide in learning your math lesson, your Wow Math channel.